Hello students, in this video I am going to discuss two topics, program blocks and control sections in the topic that is machine independent assembler features, which is the continuation of a previous video. So let me start with the program blocks. What is program block? Program block is nothing but it contains a set of segments of code that are rearranged, that are grouped together within the single object program unit. These segments of code, okay, they can be distributed, and they can be distributed in the source program, and they are grouped together within a one program object program unit. So for example, let me consider one simple example. Here I have a source program where that source program has three blocks, three program blocks: default, cdata, cblks. And this default block has two segments. One is here, another one is here. These are nothing but code of these are nothing but a segment of code. Certain statements you can have in this, but these segments they belong to one program block, and these segments may be distributed, they may be scattered in the source program. And you have one more program block, cdata, and it has two segments where these are distributed. Okay, one is here, another one is here. And there is a cblks, one more program block, but it has only one segment. And when it is given to the assembler, what the assembler does, it groups together the scattered segments, default block, and they are grouped together into one unit. cdata segment and cdata segment grouped together into one segment, into one object program unit. So that is what about the program blocks. So here, with respect to this program blocks, we use one assembler directive, that is use followed, it can be followed by block name, or there may not be any block name. This use assembler directive indicates beginning of a new program block, or it can also indicate a continuation of the previous program block. For example, I have considered one simple example program. Here I have a use cdata, that indicates beginning of a cdata program block. Use cblks, which indicates beginning of another program block. Here I don't have any use statement, that indicates default block. That is what is the use of this assembler directive use. Now let me consider one more example program, that is from the textbook. Here I have use cdata, that indicates beginning of a cdata block. Use cblks, that indicates beginning of another program block. Here I don't have any use, that means it is nothing but a default block. Continuation of the same program. Here I have a use, that means it is the continuation of a default block. Here I have use cdata, it is continuation of a cdata block. Here I have use, that is continuation of a default block. Here I have use cdata, continuation of cdata block. So this is how we make use of this use assembler directive in case of program blocks. And what are the additional operations, additional steps are carried out by the assembler. So these are the additional steps that are carried out during pass 1. For each program block, it maintains separate location counter, and for each label that is found in the program block, and it assigns an address that is relative to the beginning of the program block. And at the end of pass 1, the current location counter value indicates the length of that block, and this is used to assign the starting address in the object program for that block. And at the end, a block table is constructed. In pass 2, a machine code has to be generated For that, it calculates the target address of the symbol. How it calculates? It adds two values. One is location of the symbol relative to the start of its block and starting address of that block. Let me explain with an example. A same simple program I have considered. If it is given to the pass 1, at first it assigns these location counter values, and for each program block separate location counter sequences are used. Separate starts from 0, and use C data means again location counter starts 0. Use CBLKS means again location counter starts with 0. So these are the location counter values. At the same time, it also makes entries into the symbol table. Okay, for every symbol it maintains to which block it belongs. Here block number is used instead of block name. Block 0 means default block, 1 means C data block, 2 means CBLKS block, and along with the block number, it also stores its address that is relative to the beginning of its block. So for example, SD, its value is 003. You can see here SD, its value is 003, that is relative to its block. Okay, so next it also constructs one more table, that is a block table. When it finds end of a current block and beginning of a new block, it makes entries into this block table. What are the entries? The block name, say for example default, and its number, and its starting address, and the length. Here the length is 66. You can see why it is 66. Default block is thus till here. 63 is the address for SDA SD, and since it is based on format 3, its total number of bytes reserved will be 3. So 63 plus 3, it will be 66. So that is the nothing but the length of the default block, and that is used as the starting address for the next program block. And the same way you will have the length entry. C data length is 6. You can see why it is 6. C data length starts with 0. Next it will be assigned with the next location counter value is 3, and SDRSW1 means SD is a name that will be reserved with one word, and one word means it is 3 bytes. 3 plus 3, so it is 6. So the location counter value 6 is nothing but the length of the C data, and that is used to find the address of the CBLKS, starting address of the CBLKS. Okay, so now this is done in pass 1, and in a pass 2 the machine code is to be generated using these two tables, symbol table and block table. One example, STASD at location counter value 63, and it is of block 0, that is default block. So it is based on format 3. Okay, so in format 3 it starts with a PC relative. So in a PC relative, the displacement is calculated as target address minus PC. So what is target address? Target address is target address of SD. How it is computed? SD address you see, that is 003, and you see the starting address of the block in which it is defined. It is defined in C data, and its starting address is 66. So this will be added, and this is taken as a target address of SD. Okay, now this is used minus PC location counter value at this line. Location counter value at this line is address of the next instruction, that is nothing but 66. 69 minus 66, it is 3. 3 is nothing but a displacement. This is how informatory the bits appear. So this is opcode, this part is opcode, and these are flag bits. This is displacement, and you will get this machine code. So this is how the machine code is generated for the statements in the program blocks. Okay, next let me continue with one more topic, that is control sections. Control sections are the segments of code which are translated, which are assembled into independent object program. Separately they are translated, and they are loaded separately, assembled separately as well as loaded separately. Now here in this control section, the assembler directive start gives the name to the first control section, and beginning, if you have any other control sections, they are indicated using the assembler directive csect. So that this is the general form. Section name csect. One example is add no csect. That means the source program has one more control section. The control section name is csect. This one control section name is csect. And one more about this control sections. In one control section, that is instructions in one control section, they may use data or instructions of other control sections. So such references are called as external references. For example, very simple program I have considered here to discuss about this. You see here we have one control section, and this is another control section. As I told, we will be making use of assembler directive csect. In this case, it indicates another control section. The name is add no, and start indicates the name of first control section. So totally we have two control sections in this. And one more point I have told, that in one control section, an instruction can refer the data of other control section. For example, you see here in csect control section, we have one statement LDA plus LDA x1. What is x1? X1 is of first control section, that is main control section. X1 is defined using word, and that one you have used. This is what is external references. External references means a control section can refer a symbol of other control section. Okay, a control section can refer a symbol of other control section. It is not defined here, X is not defined here, but it is defined in another control section. So such references we call as external references. That is what we have here, external references. Now with respect to these control sections, we have a few more assembler directives that we will be using. We have one assembler directive extdaf that indicates the names of the symbols that are defined in this control section but may be used by other sections. We have one more assembler directive extraf that lists the symbols that are defined in another control section but used in this control section. Okay, same example. Here we have a extdef. extdef, it indicates the list of the symbols that are defined here. that are defined here but used outside. Okay, then we have one more assembler directive, extref. It lists the symbol that is of another control section but used here. That is what? External reference. So these are the two additional assembler directives. You see this extref. What do you mean by extref? It lists the symbols that are used here but defined in another control section. External references, we call x1, x2 sum in this as external references, and in this add NO is external reference because it is defined here, and x1, x2 sum, these are external symbols which are defined here. Okay, now if this program, the simple program that I have considered, if it is given to the assembler, what that assembler does, separately assembles. It performs the translation independently for each of these control section. First control section is independently assembled. Second control section is independently assembled. You can see the location counter value, and here separately means again location counter value 0, and separately it generates the machine code. Totally independent. It doesn't groups together, it doesn't combines together. Separately it handles the assembly of these control sections. And you can observe here, these are the location counter values depending on the size of the instructions, and you can see plus j sub. Okay, it is actually based on format 4 because plus means extended format, that is format 4. So here in format 4, if you remember, we have 3 fields. What are the 3 fields? 6-bit opcode, 6-bit flag and 20-bit address. So in this 20-bit address, if you observe, all zeros are placed. Actually in the 20-bit address, it should place the address of add NO, and instead of placing the address of add NO, it has placed 0. Why it has placed 0? Because while performing the assembly of this, it doesn't know what is the address of add NO, because this add NO will be separately assembled. Okay, so at the time of generating the machine code for this, it doesn't know address of add NO, so it just places 0 in the 20-bit address. You observe this control section again, plus LDA X1 format 4. In the format 4 20-bit address, you can see 0. Actually it should have placed the address of X1, but while doing the assembly of this control section, they doesn't have any idea about what is the address of X1, so it doesn't know, so it places 0. Similarly for this, for X2 also, for sum also. So when this is given, two control sections are given, separately independently assembles, and wherever the external references are there, these are external references. Wherever the external references are used, it just places the address as 0. Then once the assembling is over, assembly process is over, it is given to one more system software that is called as loader. Again the loader separately loads them. That is what control section. Control sections are nothing but segments of code which are assembled independently and loaded independently. So loading also done independently. Here also independent. Independently means separate locations, not contiguous location. Separate location for this, for this. Okay, so it loads independently. Loader loads independently. One, for example, in this case starts with 2000. In this case it starts with address 3000, and it does one more operation wherever the external references are there. Okay, that is here add and okay, the address which was replaced as 00 by assembler, it will replace it. 00 will be replaced with the actual address of add and add and address is 3000, so 3000 is placed here. Okay, and you consider with respect to this control section, here we have external reference x1. Since assembler was not knowing what is the address, so it has placed 0. And what the loader does, wherever the external references are there, it will replace its address, actual address. What is the address of x1? Address of x1 is 2004, and 2004 is placed here. Okay, so during loading, it loads, and wherever the external references are there, I have highlighted with red font, red colored font. Wherever the external references are there, they will be replaced with the actual address. So this 00 is replaced with the address of x1 2004, and this is replaced with the address of x2. What is address of x2? 2007. So this is how the external references are replaced, and this process we call as linking. This is important concept that we see it in the second module. So loader performs linking, that is replacing external reference address with their actual address. So now, as I said, this loader performs linking, but how it has to come to know that this address should be replaced, this should be replaced. Okay, this at these places it has to perform linking. So that is indicated by assembler by making use of a few new records. So in the object program, which is the output of the assembler, it has to indicate to the loader that external references should be linked. How it indicates? By making use of 3 more records in the object program. You know that in object program we have the records such as text record, header record, end record, and modification record for the relocation. Here we have 3 more records. One is define refer, another one is modification record, that is revised. Okay, here define record is used to indicate what are the external symbols. So this is the format. Column 1D, 2 to 7 name of the external symbol, and 8 to 13 the relative address of the symbol within the control section, and the same is repeated if there are few more external symbols. And this is the format of the refer record. It lists the external references. It starts with a column number 1 with containing R, 2 to 7 name of the external symbol, that is external references, external reference symbol, and names of other external references. We have one more record, that is a modification record, particularly revised modification record, that contains these fields. Column 1, letter M, 2 to 7, the starting address where the replacing has to be performed, that is nothing but linking has to be performed. and the length of the address field to be modified, and the modification flag, it contains plus or minus. Plus means add the address, minus means subtract the address that is during the loading. And 11 to 16, the external symbol names. Okay, so this I will explain later. If I consider with respect to this, if this is the output of the assembler, that is object codes, it has to generate one more object output, one more output, that is object program. This is the object program. As I said, object program means you have different records, starting with header record for the control section, main control section. This is header record. Then you have a defined record. Defined record, as I said, it lists the external symbols. So in the first control section, we have these symbols which are defined in this, and their addresses. Okay, so that is the content of defined record. Now we have one external reference, and that will be listed in refer record. This is defined record, this is header record, this is defined record, which indicates the external symbols that are defined here, and our refer record that lists the external references. Okay, now this is a text record, and here we have one more record, that is a modification record. Particularly it is called as a revised modification record, that indicates where all linking has to be performed. So the these are the different fields. First letter M, then 2 to 7, the starting address where the address has to be modified, and the length of the address field to be modified. Plus means the loader has to add the address of which symbol. Okay, so here if I consider this example, okay, you know that for the this it will generate header record. Then for this it will generate a defined record. For this it will generate a refer record, and for all these it will generate text record. Now it has to generate one more record, modification record, which is revised modification record, which indicates what the loader has to perform linking. Okay, this has to be replaced. With the address. So assembler was not knowing what is the address of the add and o, so it has just placed 00, but it has to be replaced with its address. So where to replace? So that is indicated by modification record. Modification record, here it starts with the letter M, then 2 to 7 column contains the starting address of this field to be modified. What is the starting address? You can see here J sub starts at address 0. Okay, that is its opcode 4B, and 10 starts with the address 0001. So that is nothing but starting address of this field to be modified. So that's what we have in modification record in the column 2 to 7. Okay, this is length in half bytes, address field length in half bytes. So about this we have discussed in detail in the previous video. The same concept here it is used. And plus means the loader has to add the address. Okay, similarly we have this object program for the second control section. Control section name is add and o, and this is header record, this is refer record, this is text record, and here we have 3 modification records. Why 3 modification records? Because the loader has to perform at 3 places the linking. Okay, so where all the linking, that is indicated by M modification record. Here you can see the starting address of this is 001. Okay, that is what we have here, 001, and for x1. Okay, next one more modification record whose address field starts with the address, what address, 004 plus the next is 5. Okay, so that's what we have here, 05, and for x2. Similarly for sum. Okay, so this is how the object program is generated by assembler that indicates linking to be performed by loader. Thank you.